Hi, everybody. We are back in Algebra 1, and I am starting on page 24 in the skinny packet. And before we move into the next section, I just want to review with you the basic rules of exponents that we need to be aware of. So first of all, there are the basic rules that we shared with let me just jump back. And I'm on page 22, that if you are multiplying with the same base, you can add the exponents. Remember, you keep the same base though. If you are dividing with exponents, as long as you have the same base, you can subtract the exponents. You will have to think about where your answer ends up. And again, if more x's are in the denominator, then your amount of x's that you end up with should be in the denominator. And if you start with more x's in the numerator, then that's where your x's should end up, is in the numerator. Don't get confused with subtracting exponents, that you subtract their coefficients. These follow the basic math of rules. A fraction that we would simplify, 18 divided by 3 is 6. And then the last rule was, if you have an exponent, a base and an exponent, to another exponent, then you multiply the exponents. I always like to think of the parentheses we distribute that exponent in. And also that if you have, something that doesn't look like it has an exponent, there's a first power. So as I wrote down here, when we distribute to here and multiply it, we can distribute it to the 1 and multiply and get 2. There are the other rules, which I really glossed over. So we're just going to touch base about those one more time. So there's one rule that says anything to a 0 power is worth 1. And then there's a rule that says negative exponents move things. So if something starts out in a numerator position, the negative exponent says move it to the denominator. And if it starts out in the denominator, then you have to move it into a numerator position. So you can see these two examples here. Okay? Once they move, they lose their negative exponent status. So real quick, why does that work? Well, in chapter 2, when we did exponents, so let's just take a small exponent, 2 to a power, and if I were to make a table with this, then what's going to happen is, let's just pick some numbers. If I take 2 to the second power, that means, 2 to the second power, which just means 2 times 2, and I get 4. This says take 2 to the first power, which that just means there's 1, 2. And then there's this rule of anything to a 0 power is 1. So why is all of that happening? Remember, when we talked about this, we have the y-intercept. So technically, it's like there's a y-intercept of 1. And that's what you begin with, 1. Remember, y-intercepts have x value as 0. And then g, the growth factor, is what you multiply by. So 1 times 2 is 2, 2 times 2 is 4. And if you want to get the other numbers, then if I'm multiplying by 2 this way, to get the other numbers, I could divide by 2. So 1 divided by 2 is a half, and 1/2 divided by 2 is a fourth. So if you had a half a cup and you cut it in half, you would have a fourth a cup and a fourth a cup. So going back to this negative exponent thing, this says take -1 and put it in there. And again, if I put it in there, I don't really have a lot of room. The negative says move it to the denominator, and once it moves, it loses its negative value, and now we're at 1/2. And then 1 to the 4th power, I get from putting -2 in for my exponent. The negative exponent says move it down, and then it becomes positive, and then that's how you get 1/4. All right? So that's kind of explaining why anything to a 0 power is 1, and what happens with negative exponents, that they move. All right, so that's kind of the long explanation. We really want to use these rules. And then the other ones, the quotient rule. Again, it's kind of the product with the power of a quotient rule. So if you're dividing in here and you have those parentheses, when you distribute that exponent in, it will distribute to everything in the numerator and everything in the denominator, like this. And if you have a couple things in your parentheses, then that exponent will distribute to each thing, as you can see here. And again, when you distribute, you do that multiplying. So those are our big basic exponent rules. Let's start moving on. In section 7.2 now, what we're going to look at is how do you add these polynomials, how do you subtract them, and how do you multiply them. When you get into Algebra 2, you learn how to divide them. Doesn't that sound exciting? So, different teachers might explain this a different way. What I like to do when I explain adding polynomials for people who are maybe new at this is to go back to when you were adding in elementary school. And if I had a number, I'm just finding something to write on, like this, 324 plus 16. And what we would probably do is 324, put the 16 under it. We would line up our place values, the ones, the tens, and the hundreds, and we would add like that. And I think that's a great way to do this, okay? So what I'm going to do is just show you how I do this. So I would take this and add this. This is not the only way to do it. So when I think about this, remember, I want it in standard form, and I want my common like things to line up, just like the ones line up, the tens line up, the hundreds line up, etc., etc. All right. So when I'm doing this problem and I start with x cubed, x squared, and x, that'll be my top row. And then, all right, I had to do a little pause in the video, but let's go ahead and get started. So I'm going to take the first set of parentheses, write it down. If it helps and you want a coefficient in front of that x, you can put a 1 there. And then when I put this, I'll put it underneath its like term. So I'll put the 3x squared with the 2x squared. I'll put the 2x with this. And then minus 3 is just going to kind of get its own category. And then I'm going to just add like I would have in elementary school. Now the nice thing is I don't have to go, from the right to the left side. You can do this however you want, because nothing's going to carry. So I have 3x thirds, I have 5x squareds, I have 1x minus 3. Now, just a reminder, since we're, talked about this in our first section, I would name this a cubic because the highest exponent is a 3. And since there's 4 terms, I would call this a cubic polynomial. Now, subtracting's a little different. So again, I'm going to do the same thing, but what I want you to realize is the subtraction tends to be the one that gets most people. So when you see these parentheses, it's because when I subtract, I'm subtracting 8x squared, I am subtracting 3x, and I am subtracting an already subtracted negative 15. And I think that this gets a little confusing, people, when you start to subtract and you already have subtraction built in. So what I'm going to suggest, and not that you have to do this, but I find it really helps me, is I like to go through and just change my subtraction into addition. And so when I do that, here's that same sticky note. If I have 3 minus 7, what I like to do is turn this into an addition sign. So I do this thing called add. We're going to make the really small opposite, and I'm going to abbreviate opposite. And I will make a pencil mark for the word add, and I will make a pencil mark for the word opposite. So I'm going to add, and then I'm going to move to the term behind it. I'm going to take the opposite of 7 and turn it into negative 7, because I really believe we're better at addition than we are subtraction. And so this would give me negative 4. Now, if I have 3 minus a negative 7, then when I do add the opposite, I'll add, and then I'll take the opposite of negative 7, which is 7. And then that turns into 3 plus 7, and I get 10. So keep that in mind as I go through these. So when I do this adding the opposite thing, and I could have done it up here, I just chose not to, I will start from the left, and I will go to the right. The first set of parentheses tends to go pretty well, but not always. So I look for my first subtraction sign, which is here, and I want to make sure this stands out, and I'm going to add. There's my 1 pencil mark, and then I'm going to take the opposite of 15 and make it 15. Now, when I subtract here, remember I'm subtracting this, I'm subtracting this, and I'm subtracting this. So this is where this whole adding the opposite thing tends to go on some people. But what I'm going to do is I'm going to add and take the opposite of this term. That one's done. And then I go back, and when I realize I'm subtracting this, I'm going to add, and then I'll take the opposite of this term. And then when I'm subtracting this term, I'll add, and when I take the opposite of this, I can think of this as a negative 15 that I'm about to turn into a positive 15. So what happened is when you go through each of these terms, I changed one thing about it. 8x squared, the opposite, that was my one pencil mark, became negative. The 3x became a negative, and the minus 15 became the adding of 15. So I just changed one thing about it. So now what I'm going to do is write my 10x squared. I am going to put a 1 here because I feel like this helps. And now it's addition, which is to me much better, and I'll put negative 8x squared with that, negative 3x with the 1x, and 15 with the negative 15. And then I can just combine my like terms. So here I get 2x squared. Here I get plus negative 2x minus 2x. It's really up to you. And then these actually just cancel out. So when I'm done, I have what I call a quadratic because of its second exponent. And since there are two terms, it's called a binomial. So let's try that one more time. Yeah. All right. So I see a subtraction here. So this is the only time I really focus on the adding and opposite. So I'm going to go left to right, and I see subtraction, and I'm going to add. And then when I look at the term behind it, I'll take the opposite of 3x, which is a negative 3x. Now when you get to the negative subtraction sign, you realize it applies to this. I'm going to use a pencil here. And I should be subtracting this. So the first time I add, I'll take the opposite of this term, which is 2x. And then when I subtract this term and I add, the opposite of subtracting 7 is adding 7. So now I'm going to write my problem, 4x squared plus negative 3x plus 6, and then I'll put this below it, like terms with like terms, negative 2x plus 7. And now I can add. I have 4x squared. I have a negative 5x, or I could do minus 5x, and then when I get this, I get 13. So when I name this, this is a quadratic. That's a very sloppy 2, but a quadratic. And since I have 3 terms, I call it a trinomial. All right, the next one, how do you multiply? So you know this as the distributive property. Maybe you did this in middle school and you heard of FOIL, where you multiply. So I don't like FOIL, so I'm going to write it in pencil. I'm not keen on this idea. You multiply the first terms of each set of parentheses. You multiply the outside terms of each set of parentheses. That's the O. You multiply the inside terms, and then you multiply the last terms. So FOIL only works if it's a binomial, 2 terms, multiplying a binomial with 2 terms. Now, real quick, a reminder, terms are the things separated by addition, subtraction. So this set of parentheses has 2 terms. This set of parentheses has 2 terms. I would call this a linear, because it's a first power binomial, and this is a quadratic binomial, lots of vocab. Oh, I totally lost what I was going to say there. Otherwise, so I was talking about terms. If you look at each set of parentheses, this is a factor and this is a factor because factors multiply to each other. And that's really important when we get to a later chapter, that these are factors. So what I like to do is I nickname this the neighbors meet the neighbors. We're just doing the distributive property. So when I say the neighbors meet the neighbors, you know, this is one apartment and this is one apartment and they're sharing a wall. They're right next to each other. So they better like each other. So 3x leaves the apartment and goes over to meet the neighbors. And so when I multiply, this is what we did with our exponent rules, 3x and x squared, that means there's 3x cubed. And when 3x distributes or meets 1, I get 3x. And now that 3x has met everybody, well, now the other person has to go over and meet the neighbors. So when you distribute this into here, you get a negative 2x squared. And when you distribute this to this, you get a negative 2. And this is it. I mean, I can't write this. I can't combine any like terms. If we were to write it in standard form, I would do the cubed. That should be a minus. Minus the 2x squared, then the 3x, and then the minus 2. And if I were to name this, this is a cubic. And because we have 4 terms, we would just call it a polynomial. So basically, everyone's got to meet everyone. It's kind of like that handshake problem I'm sure you've heard about. Everyone's got to shake hands. Okay? All right, so let's take a look. There's a few more on the back. So the reason why I don't like FOIL is because I wouldn't have a first, outside, inside, last. So this is where I see this, it's distributing. I think of the neighbors meet the neighbors. So the first neighbor to go meet everyone are these three. So 2x is going to multiply to this, and I get 6x squared. Then 2x is going to multiply to the 2x, and I get 4x squared. Sorry, this is a mistake. This should have been 6x cubed. Because I have 1x and 2x's, I'd add those exponents, and that's 3 exponents. So last one, when 2x meets the minus 4, I get minus 8x. So 2x has gone to meet all the neighbors, and now the minus 5 will go to meet all the neighbors. So minus 5 meets 3x squared, that's a minus 15x squared. And what I like to do is stack it with its like term, because eventually I'm going to have to add those up anyway. And then when minus 5 meets the 2x, I get a minus 10x. And when minus 5 meets minus 4, I get a positive 20. And now I can combine my like terms. This drops down. If I add these up, I get negative 11x squared, or I could do minus 11x squared. I get minus 18x plus 20. So if I were to name this, this is a cubic. And since there's 4 terms, I'd call it a polynomial. Just some other words for you to be aware of. This is factored form. This is standard form, highest to lowest power. All right. And again, when one thing multiplies something else, this is considered a factor, and this is considered a factor. All right, last one. So this 3x minus 1 to the second power. What I don't want you to get confused with is that rule that says we can distribute that in. That doesn't work for this. When I showed you this rule of distributed in, I showed you that it meant there were actually 2 of these 3x minus 1s, which is very different from the other thing, because inside the parentheses there was no addition subtraction. With this, it's very important to write up that there's 2 of them, and now the neighbors will meet the neighbors. So 3x goes to meet everybody else, and I get 9x squared. And then when these meet, I get a minus 3x. And then negative 1 will go meet the neighbors, and I get another minus 3x, which I like to stack my like terms. And when these meet, negative 1 and negative 1, or subtract 1, you get plus 1, positive 1. So now I add my like terms, 9x squared minus 6x plus 1. If I were to name this, this is a quadratic. 3 terms makes it a trinomial. Again, for vocab, this is a term, and this is a term, and this is a term, and this is a term, but each set of parentheses is what we call a factored. So this is what you will eventually know as factored form, and this is standard form. And in a later chapter, we're going to practice how do you go from one to the other. So right now, we're just going from factored form to standard form. And those are our notes for Chapter 7.